So we're doing a warm up for the quiz. That's afternoon at 10 o'clock today. So take a look over here. You're going to pick, because like I told you, we're going to do one problem from question 31 on the closed interval from question 31 to 46. And then we're going to do one question, so that's a union, from the closed interval 57 to 66. So you get to pick one question from this interval as a warm-up and one question from that interval as a warm-up. And a little reminder from those intervals, we already did 33, 39, 43, 46, 57, 59, 60, 61, 62. Boy, I almost passed out. So, choose. You got two questions. One, I'm going to give you a function, and I'm going to ask you part A, part B, part C. And then the second question, I'm going to give you a function, and you have to give me the domain using interval notation. So pick one from the closed interval, 31 to 46. Forty-one, okay. And pick one from the closed interval 57 to 66. And we already did 57, 59, 60, 61, 62. I'll give you a hint. It will not involve a radical. Will not. Okay. It will not involve a radical. Polynomials is always all real numbers. Done. I did it. Negative infinity to infinity, open interval, put your parentheses on it. Polynomials. Remember, domain is hurt. Domain has problems if you have a potential of a 0 in a denominator or a negative in a square root or an even root. Those are the things you have to be worried about. So 57 and 58, those have no square roots or even roots. Those have no denominators with x in it. Therefore, the domain is all real numbers all the time. But no radical. I'm not going to give you one radical. But yes, we did 62. We were 60. Okay, let's do 60. All right. 41 f of x is equal to the piecewise function of 2x plus I when x's are less than or equal to 0 and 2 minus x when x's are greater than 0. And I just wrote down 42. 2x plus 1 and 2x plus 2. This is just less than the 0, and this is the greater than or equal to 0. 41, we want A. What is f of 1? Negative 1. Make them all cross-eyed. Negative 1. B is f of 0. C is f of 2. I'm going to give you a T. I'm going to put it with D just to give you something to think about. S of Y is 3y over y plus 5. Okay, substitution. And I'm going to want to see the work as usual. So I want to see the substitution. Substitute and simplify. No decimals unless the problem tells you to put it in decimal form. And it won't. So we want f of -1. So we plug -1 into the x. And we're going to replace the x over here with a -1. But you have conditions. What it says is f of x equals 2x plus 1 if x that you're plugging in, if the value of the x that you're plugging in is less than a 0. F of x is equal to 2x plus 2 if what you're plugging in, what you're substituting, x, is greater than or equal to the 0. So if I'm plugging in a number that's, or any value that's less than a 0, I plug it into the first piece. If I'm plugging in something that's greater than or equal to 0, I'm plugging it into the second piece. So -1, does it go into the first piece or the second piece? First piece. Goes into the first piece. So f of -1 is equal to 2 times that x becomes a -1. So it's 2 times that x is now a -1. And then we go plus 1. So f of -1 is -2 plus 1. So f of -1 is -1. So in the quiz box, you have the problem, show your work. Down at the bottom of that box, it says, what does f of 1 equal? So there's something at the bottom of the box waiting for you to fill in. You finish your problem right there. You have the answer. You can put a circle around it. You can put a little happy face next to it. You can even put a star next to it. But if you don't write your answer in the space that's provided, that's -1. Write your answer in the given space if there's something provided. That's like, I want to be able to easily find your answer. Then I go back and check the work. It's kind of like if you had a scantron and didn't bubble in the answer. It would be marked wrong. So down here, I just put -1. Fine lunch.
Okay, right there on the little line.
A little line.
Yeah, it's infinity.
Oh, well, you're not doing the integral for this.
Okay.
It's just what is the answer when you plug in -1, you get -1.
Oh, okay.
Remember, these are ordered pairs. Domain, the domain, -1 went in, the range, -1 came out. Domain is the x's, range is the y's. So it can be written as this is an ordered pair, not an interval. How do you know the difference? Context of the question. If we say find the domain of the function, now we want to know all the values that we are able to plug in. So that's going to be an interval. If we're just looking for the ordered pair or write the answer as an ordered pair, now you know it's an ordered pair, it's an x and a y. Okay, 0. So does it go into the first piece or the second piece? Second piece. Because the second piece, that's when you plug in x's that are greater than or equal to the 0. So that's the one you use because that has the equals. So f of 0 is going to go into the second piece. So it's going to be 2 times that x. So I know 2 times 0 is 0. I know that. But I'm telling you, establish good habits. It's about habits. Even the simplest questions, when you plug something in at the simplest times, if you always do the same thing over and over and over, you won't mess up when something difficult comes up. Okay, it's just fundamentals, good habits. And then we add plus 2. So f of 0 is 0 plus 2. So f of 0 is just 2. Down at the bottom of the box, waiting for your final answer. 2. And now we want f of 2. So 2, is it less than 0 or greater than or equal to? Greater than or equal. So we're going to put 2 into the second case. So f of 2 is equal to, we plug that 2 in for that x, so 2 times, and we substitute 2 into the x, and then plus 2. So f of 2 is equal to 4 plus 2. So f of 2 is equal to 6. Down here, waiting down here at the bottom of the box, f of 2 is equal to, you put 6. All right. Just a heads up. If I gave you h of x was equal to, and I'm just going to pick one, the first or the second, I don't care what. First one, okay. So that's just 2x plus 1. And I say, all right, I want you to do h of x minus 10. What is h of x minus 10? So this is where I was talking about my freshman summer experience at UCLA, my surfing TA, Matt, and it's where he went in the F of happy face and F of monster. So what we're saying is, when we want to take h, I'm just going to move it over here so I don't interfere with this question here. H of x minus 10. Here's what it's talking about. Whatever you plug in for x, you multiply by 2 and then you add 1, no matter what. If I plug in 10, or if I'm sorry, 10 is a bad example. If I plug in 90, 2 times 90 and then plus 1. If I plug in -8, 2 times, that becomes -8 and then plus 1. If I plug in happy face, h of happy face, that becomes, that x is now a happy face and then plus 1. Whatever I replace the x here, whatever this is now, is going to replace it there. That means it's going to replace that right there. So whatever goes in is going to get multiplied by 2. So this x minus 10 is going to replace that x right there. So it's going to replace that as an x minus 10. Because it's 2 times, and that's two terms, a binomial. It's 2 times, put it in parentheses. 2 times, I'm substituting x minus 10. And then don't forget, you have a plus 1 afterwards. So that x is replaced with x minus 10. Now we simplify. H of x minus 10 is equal to, distribute, 2 times x. 2 times -10 is -20, and then you still have that plus 1. So h of x minus 10 is equal to 2x. -20 plus 1 is -19. So down here at the bottom of the box, h of x minus 10 is equal to, and you get 2x minus 19. So you're not solving anything. You're not solving anything at all. When I plug x minus 10 into the x, I get 2x minus 10. That's for. Right. Domain. For us right now, the only two things that we have to worry about that interfere with an all real number domain from negative infinity to infinity. The only thing that can mess us up are these two possibilities. The two bad things that might happen. The bad stuff. If you get a number over a 0 in a denominator, or you get an even root of a negative. Those are the two things you have to be aware of. Those are the two things you cannot let happen. Those are the two things, if there's a potential of getting a 0 when you plug in something into the function, in the denominator, or a negative in an even root, now you got work to do. Now you have to establish and figure out what the domain is. You have to figure out, and this is the hardest thing to wrap your brain around. You're not necessarily, in a way, solving anything. You're trying to answer the question, what can I use? What can I plug in for the y? What is y allowed to be? The numerator, perfectly fine. The numerator can equal 0 all day long, because 0 over a number is just 0. You get to learn from the other class on the stage. They looked at the numerator and they said, well, first of all, they just went, oh, y can't be 0. And they just walked away. Because they're just wrapped around. It can't be 0 down here, so you just can't plug in a 0. Well, if I go s of 0, I get 3 times 0 over 0 plus 5. I get 0 over 5. That's okay. That's a 0. That's a defined value. You can plug in 0. You can't plug in a number that's going to give you 0 down below. The denominator can't be 0. So it's not, you can't plug 0 in. You have to consider the whole denominator. This cannot equal 0.
So maybe a few hours.
Right. Or 3 times 12. Yeah, 12 couldn't be in the denominator. 3 times 12 over 0, 36 over 0. That would be that. If 12 was the wrong number. So what y plus 5, what can y not be? Negative 5. And you can visualize that. You can see what times or what plus 5 makes 0. Negative 5 plus 5. That's what cancels out 5. That's what gives us 0. This, you take the denominator, y plus 5, and basically that denominator cannot be 0. So you just go, all right, cannot be 0. Subtract 5. Y cannot be negative 5. So visually, now here's the deal. We would, in the old days, in earlier classes, you would say the domain is all real numbers except y cannot equal negative 5. That's a mouthful. So what does that look like? Well, on a number line, maybe 0. Negative 5 is over here on the left. You can't use it, so there's an open circle over here. But you can use everything else except the negative 5. You use everything to the left and everything to the right. You just can't use negative 5. That's the visual. I mean, and I give you the visual because sometimes the visual will help you get the interval. You don't have to draw the interval. You don't have the number line. You don't. But if you're having trouble setting up the interval notation, not a bad idea. So now from left to right, the interval of domain, all the way down there forever to the left is negative infinity. Remember, infinities are always parentheses. And the numbers that you can use go all the way from negative infinity, and they stop when you get to negative 5 because you can't use it. Because that's an open circle, because you can't use it, it's a parenthesis. You can use everything from negative infinity up to negative 5, but don't use negative 5. And then on the other side, this side, it starts at -5 and it goes all the way to positive infinity. And it's a union. So in between, you got to put the union of those two sets. Okay, that joins them together. So the domain is all of the numbers in this interval joined together with all the numbers in that interval. Okay, again, a little bit of learning from the other ones. If I made this 4y plus 1, does the method change? And 4y plus 5 and 3y plus 1. Does the process change at all? I don't need to. Well, think of what was the process that we just did? Yeah, the denominator, right? The numerator, we don't care about. The numerator can equal 0. And again, here's the rub. If I just plug in 0, 3 times 0 is 0. 0 plus 1, I get 1. 4 times 0 is 0. 0 plus 5, I get 5. I get 1/5. I plug in 0. 0 works. Y can equal 0 perfectly fine. So what can y not equal is what you got to worry about. Well, if you take the numerator, and some people do, they go, what, 3y plus 1 equals 0, subtract 1, 3y equals -1, divide by 3, y is negative. So that means y cannot be -1/3. That's the numerator. If I plug in -1/3, I get 0 over -4/3 plus 5. That's fine. That is 0 over a number that's 0. That's perfectly fine. The denominator is your worry part, your concern. So what they did here, if they just would have used the denominator, this 4y plus 5 cannot be the 0. When you have a rational function like that, rational means ratio, ratio means fraction. The denominator cannot equal 0. That's your concern. Subtract 5. 4y cannot equal -5. Divide by 4. So y cannot equal -5/4. So just to get the visual, -5/4 is over here to the left of 0. And there'd be an open circle, and you can use everything but that. From -infinity all the way up to -5/4. Union, everything from -5/4 to infinity. If you notice, I use fraction, not decimals. Because the directions are going to say no decimals unless told to use decimals. Okay. Denominators can't be 0. Even roots can't have a negative inside. That's your concerns on domain. All right. So the last that we have to do from 1.3 examples is your choice, and I'll pull it up, 83 or 85. Remember, your quiz at 10 is open note.
-5/4 would be close by to it.
No, you cannot use it.
Oh,
Everything up to that open interval parentheses, and then everything from there to, so you can't use it. If I put a closed bracket here, that means that's used as a solid circle. That means why would I even have it if I went from, if I did this, a closed bracket, and that means closed bracket over here, that's because that's a solid, which means I wouldn't use this notation, it would just be negative infinity to infinity. Because that closed bracket connects the two together right at negative 504. Good question. Okay. These are difference quotients. Difference quotients. And you're supposed to make substitutions in 83. You're given this function, f of 2 times x, and they want you to plug this into it. Rewrite it using this notation. 85, f of x is x squared minus x plus 1. And they want you to do f of 2 plus h minus f of 2 all over h. So what you all see? Page 35.
85.
Of course. All right. So as you can see, they do put the condition on there. H cannot equal 0 because if it does, look what you get. If you let H equal 0, 2 plus 0 minus f of 2, all over this H would be a 0 if I plug 0 into the. So that's f of 2 minus f of 2 all over 0. F of 2 minus f of 2, well, they would be the same number. That gives you 0 over 0, which is not 0. It's not undefined. It's, I don't know, it's indeterminate. When you get 0 over a number, that's a 0. When you have a number over a 0, that's undefined. But when you get 0 over 0, if 0 is in the numerator, you're supposed to get 0. When 0 is in the denominator, you're supposed to get undefined. When you have a number divided by itself, it should equal 1. 0 goes into 0 one time. 5 goes into 5 once, 0 should go into 0 once. So that's 3 possible answers for the same question. In math, that's not what we do. If there's 3 possible answers to that thing, then we don't know what it is. Which means indeterminate. Can't be determined. Which means hello calculus. That's where we handle calculus. Okay. So to get to the calculus, we actually have to be able to do the substitution first. So first thing you're going to do in the numerator, you want to replace x with a 2 plus h. So we're gonna replace this x with a 2 plus h, which means every x gets replaced with a 2 plus h. Now, because you're replacing x with two terms, put it in parentheses when you make that substitution. So this x squared is now parentheses 2 plus h squared minus that x is a 2 plus h. So minus parentheses 2 plus h. And the rest of the function for f of x is, don't forget to put the plus 1. So this first part is my f of 2 plus h. Then what they want from us is minus f of 2. So this first part, the screen is not good. This first part from here to here is the f of 2 plus h part. Now you're supposed to go minus the second part is going to be f of 2. Now, you're going to replace the x's with a 2. So that x is going to get replaced with a 2. That means every x is going to get replaced with a 2. There are 3 terms. So it's minus, you have 3 terms. Do yourself a huge favor. Whenever you subtract more than one thing, put it in parentheses. So minus parentheses. This is huge. Because people, having taught calculus for years and years and years, APAB, APBC, this is one of the things that I struggle with. Not struggle, I would struggle with it, but I struggle getting students to correct putting frequent parentheses in. Minus that x squared is now a 2 squared. So again, good habits. If it was a negative, I would use a parenthesis. So I'm going to use a parenthesis all the time. A 2 squared minus a 2. And yeah, you can use a parenthesis there, but you don't have to. It's okay. And then you have a plus 1. And to stay consistent, I was doing whatever was actually part of the function in minus, and that's your plus 1, and the substitutions I did. Close that parenthesis. And then in the denominator, we have h, all over h. Okay, so now you have to do the algebra and arithmetic. Got it. Yes. I'm going to do this right now, and I'm not going to say anything. If you need me to explain it, I'll explain it. This is 4 plus 4h plus h squared minus 2 minus h plus 1. Now we have minus. Minus and plus 1. And minus. Inside there we have 4 minus 2 plus 1. All over h. Can I like ring a bell? Let me know. That's right, about it. I do that. I'll stand over here and wait for you guys. That's a. Somebody with it. But if you're good, I'm gonna keep going. Just don't be shy.
So what we do is you multiply it twice, right?
Yeah, so 2 plus h times 2 plus h, but I use the shortcut. I use a plus b squared because that's what's going on. So when you have a binomial squared, you square the first one, you square the a. In the middle, you multiply the a times b and you double it 2 times. You multiply the a and b together. And then because that's addition, you have a b squared. So the 2 is squared. Then I multiply 2 times h and I double it. I multiply the 2 times the h and then I double it in the middle. So that's where the 4h comes from. And then h times h squared. Or if you write it out like this, you get 4 plus 2h, and then another 2h, and then h times h is your h squared. So 4 plus 2h plus 2h is 4h, and there's your h squared. Okay. Good old algebra 1. Wait. And then distribute the negative. So 2 becomes a negative, h becomes a negative, and I still have that plus 1. And then I'm not distributing this negative because order of operations says, before I do the subtraction, finish the parentheses. So now, combine like terms. Right out here, I'm going to combine whatever like terms I have. So if we take a look here, we have a 4 minus 2. 4 minus 2 is 2. And then a plus 1. 2 plus 1, that gives me 3. And then your h to the firsts. You have a 4h minus h. 4 h's, take away 1h, that's plus 3h. And then you have an h squared, plus an h squared. So on the outside, everything is checked off. You combine everything that you can combine. And then I still have minus a parentheses. 4 minus 2. 4 minus 2 is 2. 2 plus 1, we get 3. All over h. So this becomes if you look at the 3 in front, and that's a minus 3 over here, just minus 3. 3 minus 3 cancels out, that's a 0. So we're left with 3h plus h squared all over h. Not done yet. You have to simplify when you can. And so this would be the next and basically last, second to last step in a calculus. So now this is equal to 3 times h. That has an h squared. This is an h. All 3 of these terms have a common factor. They all have an h in it. So what you do is you factor an h out. You factor out the h. And when you factor out, you're dividing. I'm dividing this one by h and this one by h. So in the parentheses, I'm left with 3 plus h over this h. And so this f of 2 plus h minus f of 2 all over h is equal to h divided by h is 1, and all you have left is 3 plus h. The last thing you would do in a calculus class is you would now take the limit as this approaches 0. So outside the entire time, you would have this notation. What's the limit as h approaches 0? Not when h equals 0, but what's the limit as this h is getting closer and closer to 0? Because if it equals 0, we got 0 over 0. If it equals 0, we got indeterminate. But as you approach 0, so 2 plus 0.1, 2 plus 0.01, 2 plus 0.0000001, 2 plus 0.00000000000000001, or 2 plus negative 0.1, because you're approaching 0 from both sides, positive and negative. Negative 0.1, negative 0.01, negative 0.001, negative 0.00000. So what do we get if we let h approach 0 from both sides? That is exactly the same as letting h equal 0. When I let h equal 0, this thing equals 3. That's how you take a derivative. That's how you find instantaneous slope of this function at the value of 2. Instantaneous slope at one point. And that's what calculus is. You need 2 points to find slope. Well, this is 1 point. At when x equals 2, the slope is going to be 3. Instantaneous. Okay. Now, the good news is you spend about 2 or 3 sections doing slopes like this. Then along come the shortcuts. And if you know your shortcuts, you can take the derivative, you can take the slope of any function you come across, if you know your shortcuts. And I'm going to do this because it was so cool. Are you aware of Bo Burnham? Welcome to the internet. Yeah, he's really funny, very intelligent, very intelligent. But this guy did a parody. So, you're going to be looking at graphs that aren't always going to have closed endpoints. So that means you might have some open circles in certain places, functions that are discontinuous. Discontinuous are functions that might not agree at a certain value. You might have one function approaching a 5 from this side, but over here it approaches a 6. So they don't agree as you approach one number from either side. You might have functions that also, in terms of discontinuity, they're approaching asymptotes. Maybe they're both going up like this. Okay. If they approach an asymptote, then it's a broken function. Or they just have a hole. So as you approach 5, x is 5 down here, the y's are approaching 3, and these y's are approaching 3, but when you plug in 5, it's undefined. Okay. This function, when you plug in -1, because that's a solid circle, we get -5. And then as we plug in x's all the way to 4, everything is a solid point. Yeah, all these counts, these are all good. There's an answer for every x value, all the way from -1, but that's an open circle. When we plug in 4, we should have got 0, but it doesn't work. So the function is not defined, because that's an open circle, just in the picture, just for the picture. It's not defined when x is a 4. So if we're finding the domain in the number line we're only using x's that start at this -1. And when we plug in -1, it's used. It actually has an ordered pair. And we're only using x values all the way up to 4. But when you plug in 4, you don't get an answer. That's an open circle in the graph. So you can get infinitely close to 4, 3.9, 99, but you don't get to use the 4 because there's no order pair. So you would shade this in. Which means as interval notation, because that's a closed circle, it would be a bracket from -1, and then it would go and stop at 4, and you have a parenthesis on the 4 because it's an open circle. And that would be the domain. Okay. The range. Now the range, it's really important that from my perspective, seeing a picture really helps me figure out the range. Sometimes you're not going to be able to get a picture, so you've got to think. The reason why students freeze on domain and range questions is because you're not just answering what is X. You have to think, what can X be? What will Y be on a range? You got to think. You have to answer the question from a different standpoint. The Y values on the Y-axis, the smallest Y value you have is right here at -5 on the Y-axis. This graph does not go below -5. So all of your Y's, they're greater than, because they're above the -5, and it also equals that -5. Okay. The Y's go up, 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 and they go as high as this point. What's the Y value up here? It's a 4. And then they come back down. We have no Y values above the 4. All of the Y values are greater than or equal to -5, and instead of an or, it's an and. And they have to be less than or equal to, because that's a solid circle, less than or equal to +4. Now, when it comes back down, right here, there's an open circle at 0. Can the Y's in this picture actually equal 0? Yes. Right here, it's a solid point when you have a 0. So Y did equal 0 over here, that's perfectly fine. And you know how you see how Y equals 1 twice, Y equals 2 twice, Y equals 3 twice? It's okay for Y to repeat. X can't repeat. So Y was 0 at least once. Now, if there was an open circle there, then yeah, Y could not equal 0 ever. But there isn't. So if you were going to look at this, it would be all the Y's have to be greater than or equal to -5. And all the Y's have to be less than or equal to +4. If I was going to do a number line, that's a closed circle because it has an equals on the -5. And all of the Y's are greater than that. Greater than would be to the right. Now I'm not shading yet because I got to figure out what's going to happen. And is different than or. Or you join the groups together. You join the sets together. So you shade whatever is left or right or whatever the groups are going together. And you're going to shade the intersection. And means intersection, and means overlap. You're going to shade the overlap. Over here, there's a closed circle on the 4. All of these Y's have to be less than. Less than is to the left. So those two arrows overlap everywhere in between. And that makes perfect sense. It's everywhere from this -5 up to that 4, everything, all those lines in between. Interval notation would be a bracket from the -5, and it stops at the 4, and because that's a solid circle, that would be a bracket. That's the range. Okay. All right. So here's one where you don't get a picture. So you gotta think about what you're trying to do. What song is that? Read the brain. I don't know. RESPECT. Yeah. I watched most of the commercials. I tried to. We had my daughter and her husband came in Saturday to Sunday morning. And so Saturday we had everybody over dinner. So I was basically working all day Sunday. It's always hard to comment. I used to be able to do work and watch TV, but I can't stand the commentary. It's like people just don't shut up and let you watch. Everybody's got an opinion.
Work at home or work at class?
No, work. It's too far to go here. When I was teaching at Buchanan, I would go to the classroom. And I miss so much of my family. There's 10 years where I can't remember almost. So I was coaching basketball, teaching AP classes, no prep period, going get my master's degree. So, all right. This is not going to be on your quiz, but hey, it's going to be on a test, I bet. Domain, x minus 4 inside. It's a square root. So you cannot take, bad things happen when you have even roots, even with negatives, it's bad. So that means the inside has to be greater than or equal to 0. That's what it means to not be negative. So the domain the inside, that x minus 4, has to be greater than or equal to 0. That works. So remember, when we're solving for the domain, we're solving for what can x be. X's can be everything greater than or equal to the 4. Give me enough, so, and this is where you kind of get a mental check. Over here, it's a solid circle on the 4. Greater than is to the right, everything to the right. So if you pick a number to the right of 4, anything to the right, give me a number. 5 or 900. Square root by plugging 5. 5 minus 4 is the square root of 1. That's the square root of a pot. That's equal to 1. 900. 900 minus 4 is the square root of 896. I don't know, and I don't care what that equals, but I know that that's square root of a positive. Perfectly allowed, perfectly fine. You know what doesn't work is something to the left of 4. Pick a number over here. 3.9. Oh, yeah, 3.99. Perfect. $3.99 minus $4. 4 is bigger than the 3.99. So when you do that, that's going to be a negative penny. It's the square root of a negative, not allowed.
So where would you put that? 0? Not allowed?
Well, you don't have to. Remember, all you want to do is what's the domain? The domain is everything from 4 to infinity. You're not gonna put what it isn't, you're gonna put what is the domain. What is it, what can it be? So without having to graph it, if I wasn't gonna graph this and I wanna figure out the range, well, the first thing I'm gonna think about is, all right, if I plug in 4, 4 minus 4 is what?
0.
And the square root of 0 is 0. So that means I get a y that is equal to a 0 when I plug in 0 for, or 4 for x. Now, when we plugged in 5, so when x equals 4, we got 0. When x equals 5, we got y equals a 1. It's going up. Remember what we talked about last week. And even before that. If you take the square root of something, can you get a negative answer? Can I take the square root of whatever's in here and get a negative? Not 0, but just something. Square root of something and it equal a negative over here. Remember, we're not solving. If I gave you x squared equals 25, we want every answer, take the square root, you put x equals plus and minus 5, because you want all of the solutions. That's solving. If we just said, what's the square root of 25, and you're simplifying, you just put 5. So can a square root give you anything out that comes negative? No. We even graph it. You have the x squared plus y squared equals out 16, and you subtract the x squared, subtract the x squared, because we're supposed to put it in the calculator to get a circle. So then we took the square root, the square root of 16 minus x squared. And if you only graph this, you only get this. Remember, we were solving for x. Since we were solving for x, you put plus and minus. So your y sub 1 was a positive 16 minus x squared. Your y sub 2 was the negative square root of 16 minus x squared. You had to put this in for y sub 1, that's the top. When you put this in for the bottom, it gives you the circle. Okay? Which means this as an equation is not a function because it fails the vertical line test. Okay. And then there was even a question that asked you, what if you were just given y equals, or in this case, yeah, what? Y equals the square root of 16 minus x squared as a starter. You didn't solve for y, it was given this. Yeah, if you're given this, it's only one of the, so it's just the top. You don't have top and bottom because you're not doing this to it. So if you're just given that, then yeah, that's a function because you're only getting the top half. So the range, when you plug in 4, the y is a 0, then you plug in 5, the y is a 1, the y's are getting bigger. Here's 4, you get a 0, we plug in 5, you get a 1. The y's are going to get bigger as you go out. So in the picture, the range, are there any points down here? Anything down here in the graph? No. I'm never, remember, in that square root, I'm never going to get a negative y value. All of the y's that are going to come out of that picture have to be greater than 0. They have to be bigger than a 0 because it's a square root. It can also equal a 0. All of the y's can be greater than or equal to 0. So no. Interval. 0 would have a closed circle. Greater than would go that way. Bracket on the 0 to infinity. That's your range. You should go make it. You gotta think it through. The only way that this could ever be less than a 0 is if after the square root of x minus 4, you go -2. So that would take this graph and then drop it down 2 units and it would go from there. At 4, you get -2. Then the y's would all have to be greater than or equal to -2. But we haven't worked on our, we haven't done any of the shifts or anything like that. Talk about vertical line tests. So look at these two. You take your vertical line and draw, basically drag it across a picture of a graph. If it intersects the graph in more than one place, it fails the vertical line test, and therefore it is not a function. So your vertical line would be your finger, or you take out your pencil. Since this graph is intersected twice, one point of x, it fails the vertical line test. This means this is x is 1, 2, 3. When you plug in 3, we have a y value. That's approximately 2.6 something. And down here, when you plug in 3, looks like we get negative 0.7 something. I don't know. The x value happens in 2 different places with different y values. If it's a function, when you plug in 3, you are only supposed to get 1 y value. So not a function. But over here, passes the vertical line test because the vertical line never crosses the graph from more than one place. That's taking a graph out. Okay. Language. Watch your language. And math, that's not taking lightly. You gotta watch your language. One of the things that slope and calculus study is when are functions increasing, when are functions decreasing, when are functions constant. So if we were just to, meet somebody on the street, we would say, hey, a function is decreasing when it's going down. And a function is increasing when it's going up, and a function is constant when it remains the same. But if we're math students, it's kind of like, well, that's not math. You try to be some kind of hippie in a math class, you can't be a hippie here. We are cultured, we are very classical, we are very specific. First of all, when you're describing increasing versus decreasing, this is what drove students crazy when they first were trying to answer the increase and decrease. If you were going to graph a parabola, you're supposed to put arrows on both sides because the domain is all real numbers. So all the way to the left forever, all the way to the right forever, and it keeps going up forever. So the function keeps getting bigger means increasing. Well, over here, it's getting bigger all the time, and over there, it's getting bigger all the time. So it's increasing there, increasing there. That was one of the stumbling blocks. And the answer is no, it's not. You have to establish we only look at the graph to determine increasing, decreasing. Read the graph from left to right. What is the graph doing as you go from the, look at the graph from left to the right? So if you were coming down this graph from this point on the left, x over here, x of 1, and you're walking the x value, not on the x-axis, but on the graph through these x's all the way to x of 2 over here, you would first have to be going down the graph. So that means as you're coming downhill, you're decreasing. The graph is decreasing going down. as you go from left to right. And then you get to the bottom of the hill. And then in order to get to this value over here where x is x sub 2, you have to start walking uphill. So now the function is increasing from this point to that point, it's increasing. And from this point to that point, it's decreasing. Because you're always looking at it from left to right. You don't have to worry about writing this down, but this is how it's handled mathematically. And when I first started teaching this, you know, I would make my students take definition quizzes where they would have to write out definitions of certain concepts. What's the definition of increasing? What's the definition of decreasing? You know, those kinds of things. Because I always was concerned about them because of my experience in college at UCLA, walking into a classroom and not having a clue as to what the professor was saying. Because the professors at a university like that they're so proud of what they know, they're just going to keep on going and espouse what they know in the language that they know. And if you can't keep up, that's your fault. So, I'm going to change glasses for you. Worry, I'll get ahead. There you are. Don't worry about writing this down, but a function is increasing on an interval when for any two x values, x sub 1 and x sub 2 in the interval. X sub 1 is less than x sub 2. So that establishes going left to right. The x sub 1 value is always to the left of the x sub 2 value. It's increasing if the f of x sub 1, so over here, increasing. X sub 1, so that's x sub 1, f of x sub 1. The y value is plus x sub 1 into the function. Over here is x sub 2, the y value is f of x sub 2. So as we go from left to right, where x sub 1 is to the left of x sub 2, left to right, this y value, f of x sub 1, is less than f of x sub 2. So this y value is smaller than that y. That means as you're going from left to right, you're going higher. That means the function's increasing on that interval that has x sub 1 and x sub 2 in it. It's decreasing. It's decreasing. Let's change signs. Over here, x sub 1. So when I plug in x sub 1, we get f of x sub 1. And over here is x sub 2. So when we plug it in, here's f x sub 2, comma, f of x sub 2. Again, from left to right, x sub 1 is smaller than x sub 2. X sub 1 is to the left of x sub 2, so we're going left to right. F of x sub 1, that y, is bigger than f of x sub 2. So this y value is bigger than that y value for all of the x and y values here, which means as you go from left to right, the next y value is below it, you're going down. That's decreasing. You're increasing if the y values are bigger as you go from left to right. You're decreasing if the y values are smaller as you go from left to right. And then it's constant as you go from left to right if the y values, think about it, if the y values are equal, so x sub 1, x sub 2, f of x sub 1, x sub 2, f of x sub 2. So as you go from this point to that point, this y value and that y value are exactly the same y values. It's constant on that interval. But again, establishing left to right. It's always about left to right. So some of the questions, just to give you a start on homework. $25. Determine the open intervals in which the function is increasing, decreasing, or constant. So here's the deal. Because you don't see arrows, but you certainly cannot tell that this thing is actually having an endpoint. You don't, that's -1 right there. But you know what? I have no idea whether or not that is an actual point at -1 and it stops at -4. So we are going to assume that these have arrows on all of these. If they meant to have an endpoint, they would put an endpoint. So if you don't see an endpoint, you can assume they go on for it. So as we go from left to the right. Increasing and decreasing. So from left to right. From -infinity, the function as your x's increase, these y values are getting bigger and bigger and bigger and bigger and bigger until you get to x is 0. Once you get to x is 0, in the next, right beyond 0, they start to come back down. So it's going to increase from -infinity all the way to 0, and it's an open interval. It's an open interval, and the directions even say, what are the open intervals of increasing and decreasing? And then instead of doing all of the increasing and then the decreasing, it just keep on going from left to right. As soon as you get to 0, then the y values start to come down. So on the next piece of it, from 0 to something, the function is decreasing because the y values are getting smaller until we get to this point. That is the lowest point, and we'll learn about that next week or Wednesday. It's called a minimum. We've reached a maximum here, and this is a minimum down here. We reach that minimum, and then it starts to get bigger again. So it only decreases from 0 until this value, which is a 2. So from 0 open interval to 2 open interval, parentheses. That's where that piece of the function is decreasing. You're getting smaller. So yeah, there would be a 0, a maximum is x equals 0. And there would, and so here I said, there's a max at x equals 0, but the maximum is considered the y value. The maximum value of the function is a 2. Because when you're trying to measure maximum to minimum, it's about what does the function do. And then after you get to the x equals 2 and you pass it, that minimum, now it starts to go back up again. It's like a roller coaster. You go up, and the next part you go down, and now you're going to climb the next one, which theoretically would be impossible if this was a gravity roller coaster. The only way you can go higher than your last drop point would be you're now on a chain taking you back up to the next height. Because if you think about potential energy and kinetic energy, this is all the potential energy you're going to get. Gravity will bring you down to here. The next has to be lower than that because you can't go any higher than your last power. Okay. If you could, that would be awesome. So it's going to increase 2 all the way to infinity. And guess what? It's a union of those 2 intervals for increase. Well, I blacked out, right? I didn't think of time. All right, quiz. So anything you want to use, have it out.